Hey guys, I just wanted to give you guys a little bit of a video just because I know that we're really struggling with ellipses and hyperbolas. So this is kind of to give you the difference between the two, and hopefully that'll help you out a little bit. So, big picture, ellipses are all bigger versus smaller. So when you're looking at the denominators here, that's what you're caring about. Which one's bigger, which one's smaller, and that's going to decide, is this a horizontal ellipse, or is it a vertical ellipse? So the number that's with x is always the horizontal number. The number that's with y is always the vertical number. So this number b squared is with the x, it's the horizontal distance, and a is with the y, and so that's the vertical distance. The other difference between ellipses and hyperbolas is c squared equals a squared minus b squared. And so this is having to do with your focus points. Okay, it's your focal length. C is your focal length. And so that's the distance from the center to the focus point. A is the distance from the center to the vertex. B is the distance from the center to the minor endpoint. Okay, so the endpoint of the minor axis is here and here. The endpoint of the major axis could also be called the vertex. And so this is horizontal because the A value, or the horizontal distance, is more than the vertical distance. This one, on the vertical ellipse, this distance here is longer than the horizontal distance. And so that's why everything is bigger versus smaller. Okay? We'll talk about eccentricity a little bit in a minute, but 0 is less than e is less than 1, so all of your eccentricity values should be between 0 and 1, and we'll talk more about that in a second. Okay, so that's ellipse. Now we have hyperbolas. So for my hyperbola, everything is what comes first and what comes second. If x comes first, then it's a horizontal hyperbola, meaning it'll look like this. Okay, that's a really bad drawing, but you get the idea. It's going left and right. Vertical, y comes first, so it's a vertical hyperbola. So it'll be here and here. Okay, so it's facing up and facing down. This one's facing left or facing right. We have the other major difference. C squared is a squared plus b squared. So we're adding the two values in the denominator together. The other thing is the horizontal and the vertical asymptotes, and we'll talk more about that on the next slide. But that's the major difference between horizontal hyperbolas and vertical hyperbolas. Okay? A squared, if it's with x, is the horizontal distance. B squared, if it's with y, is the vertical distance. Okay? Whatever's with x is the horizontal distance, and whatever's with y is the vertical distance. Alright, so there's a lot going on here. I did these separately. So this one is the horizontal hyperbola. Starting with the center. HK is your center, so you always start with the center. From the center, you go right A and you go left A for a horizontal to get your vertex. Both vertices are a distance away from the center. The vertical distance B doesn't play that big of a role except for your asymptote. And I said a second ago that A is the horizontal distance and B is the vertical distance. So just like we learned long ago in Algebra 1, rise over run is your slope. Okay, well the slope of our line is B over A. Why? Why do we care that it's B over A and the other one is A versus A over B? Okay, it's the change in y over the change in x, always. It always has been, it always will be. Okay, so this is the vertical distance over the horizontal distance. And so on this one, B is with the y and A is with the x. So this is the vertical distance and this is the horizontal distance. And so it's always B over A. So when we're graphing from the center, This is part of your line too, because that's the point that both lines are going through the center, through the center. From the center, I'm going up B, rise, and I'm going over A, run. So up B, over A, up B, back A. Okay, and so we have a negative slope and we have a positive slope. The other question I had a lot this week was the conjugate versus the transverse. So the conjugate is 2 times B, so that's this distance here. So here's B, that's the conjugate axis. The transverse axis is 2 times A. Okay, so they're not actually located here, it was just easier to see, so I wrote it there. So this is the conjugate, and it's 2 times B, and this is the transverse, because it's 2 times A. The other thing, C squared equals A squared plus B squared. That is your focal length, or how to find your focal length. And so we're taking these two and we're adding them together. So C should be bigger than A. C is longer here because we've taken that shape. Your ellipse was here, and so our focus points were inside that. Now the shape has flipped out, and so your focus points are in the center of the curved area. And so now the focal length is longer here than the vertex point. So this eccentricity should be greater than 1 for all hyperbolas because of where the focal points are. So that's the horizontal one. The vertical one is very similar. Conjugate is still 2 times B, transverse 2 times A. So A to A, so it's like vertex to vertex. Y is now first, and so the number that's with Y is the vertical distance. And so we're square rooting that and going up and down to get to those vertex points here and here. Your focus points are still outside of that, and your center is still in the middle. Same thing we had before, except now A is the vertical number and B is the horizontal number. So we still have change in Y over change in X. That's the vertical distance over the horizontal distance. And so we have here A divided by B. So from the center, because HK is my center, I'm going up A and over B. And that's how I graph that line there. The asymptotes are really just there to mark out where my graph is going and what it should stay inside. It's kind of like, hey, here's these boundary lines that I have going on here. Okay, I hope that helps with how to graph and what the numbers mean in the equation. But now let's talk about eccentricity. Okay, so let's start with a circle. So a circle is still a conic. Y'all talked about that last week. Okay, the focus points or your eccentricity is still C over A, or your focal length divided by the major axis. So if it's your focal length, that means that your focal length has to be 0. And so on a circle, because it's the same all the way around your shape, the focus points and the center are all in the same place. So your eccentricity is 0. As soon as those focus points even shift just a little bit, your shape becomes more oval, and so that's when it becomes an ellipse. And so your ellipse is between 0 and 1. So as it separates a little bit, as it separates more, the shape is going to change. So the closer you are to 0, the more circular it is, the more like a circle it is. The closer you get to an ellipse or 1, the more elliptical it gets, or the more like a parabola it's going to be, because a parabola, they're really great drawings, y'all. A parabola looks like an ellipse that's just kind of been broken, and so that's that shape has an eccentricity of 1. And so then if we continue, hyperbola, so now our shape, here's my center, but my focus point is out here. And so C is greater than A. And so C over A is your eccentricity. And so this number should be bigger than 1 now. And so that's kind of a better picture of what's happening with your eccentricities. So if you have questions, come see me on Monday after school. I will be there. Your quiz is being moved to Monday night, so you have some extra time to get that homework done and the exploration finished. Okay? Please ask me if you have questions. I want to help. Okay? Come see me on Monday. Good luck this weekend.